So, hey guys. So this is just to clarify what I was talking about in class today when I mentioned measuring diagonal angles using a scale factor. So first of all, I'm going to make the outline of my course. Just going to kind of draw random lines. Okay, so say this is a corner of my course, and I've got an angle here, and we'll say this is my water hazard. Okay, and I want to know how long this line is. So the first thing that you probably did is you probably decided on a scale factor when you drew your picture. So my scale factor is going to be, for every 2 boxes I have, it's going to equal 1 inch on my diagram. So 2 boxes is 1 inch on my diagram. So to get this side, well, it's easy. I just count. And I'm going to count by 2s because every 2 boxes is 1 inch. So 1, 2, 3, 4, 5, 6, 7, 7.5. So that gives me 7.5 inches because I counted by 2s. We can do the same thing for this side. 1, 2, 3, 4, 5. We'll call it 5. 5 inches. But unfortunately, with the diagonal, I can't just count the triangles. I could try to piece together, like, okay, maybe if I combine that one with that one, that's 1, and that one with that one, that's 2. I could try to maybe piece it together, but ultimately, I'm going to have to use a scale factor. So I've got my scale factor here, and I'm going to write it again. 2 boxes to 1 inch of diagram. I'm going to say diag. Alright. But in order to measure this line, I'm going to have to make a different scale factor. So in this case, I'm going to use handy dandy ruler. And I'm going to figure out just how tall my 2 boxes are. So I'll go down here, and I'm going to measure how tall 2 boxes are. So line that up. Okay, so that's 1/4, that's 1/2. So 2 boxes are 1/2 inch. So I'm going to write that up here. 2 boxes equals 1/2 inch. So if 2 boxes equals 1 inch on our diagram, and 2 boxes also equals 1/2 inch, well, I can just replace this with that. And my new scale factor is 1/2 inches on the ruler to 1 inch on my diagram. So this is my new scale factor. This is what I'm going to be using to measure the line. So I'm going to go ahead and measure the line. And I get just about 4.5. Okay. So now this is where proportions come into play. Oh no, Mr. T! Not chapter 4, we already finished. Sorry. But it comes in handy today. So we're going to set up a proportion using our scale factor and the side that we're wanting to measure. So we said that our side, or what we measured on our ruler, is going to be 4.5 inches. Why did I put this up here? Well, if you see, I have rulers up top on this side, so I have to put rulers on top on this side. So that means x, because I don't know how much it is or how long it is on my diagram, is going to go in the denominator. So there we are. I have a proportion that hopefully you remember how to solve. So I'm going to change my fractions to decimals because it's just a little bit easier for me to think of. So 1/2 inch on the ruler over 1 inch on the diagram is equal to 4.5 inches on my ruler to some unknown distance or length on my diagram. So to find x, we cross multiply. 1 times 4.5 is 4.5 equals 0.5 times x is 0.5x inches. Divide each side by 0.5. Divide each side by 0.5. When we divide by 0.5 or a half, we actually end up just doubling it. Oops. And that gives us 9 inches equals x. So that goes to show you that this line on my diagram, when it comes time to build, I'm going to measure out and probably cut out of the cardboard 9 inches. So you can see by using a scale factor that I made originally and then converting that to a new one using my ruler, I can find out, solving a proportion, the distance or the length of my new line. So that's that. If you have any questions, feel free to come up to me and ask. Hope this helps.